Okay, again, so again, all of this is unit 2. Now some examples on factoring. Factoring quadratic functions. You guys need to know how to factor quadratic functions. We did a lot of this. So, an example. Let's say that you get something like x squared minus 7x minus 18. What's the process of factoring something that looks like this? Something that, two numbers that multiply to minus 18 and add up to minus 7. Daniel? Negative 9 and positive 2. Does negative 9 times 2 give us minus 18? Yeah, well, let's see. Minus 9 and positive 2. When you multiply them, yeah, minus 9 times 2 gives me minus 18, which is what I wanted. Nice. Let's see if we add them. Minus 9 plus 2. Minus 9 plus 2, that gives me minus 7. Great. Definitely. These are the numbers. Minus 9 and 2. Guys, the factor is going to be x and minus 9 and x and plus 2. That's it. We did it. That's how we factor a quadratic function. That's one way of factoring a quadratic function. If you're looking for the values of x, or if you're looking, the values of x have different names. We call them x values, we call them x intercepts, we call them zeros. Okay? If you're looking for the values of x, you set your function equals to 0. Then you take one factor, you take this factor, x minus 9, and set it equals to 0. Take the other factor, x plus 2, and also set it equals to 0. So for these two different factors, solve for x. For this one on the left, I'm going to add 9 to both sides. So I get that x equals 9. For this one, I'm going to subtract 2 to both sides, so minus 2 and minus 2. And I get the x equals minus 2. So these values right here are my x-intercepts. They are my solutions. They are the zeros. Alright. Denise? Alright. Now also, given any quadratic function, the x-intercepts are not the only thing that we can find. Can we find the y-intercept of this quadratic function?
If we don't need it to find it, don't even mention it.
Well,
because that's the problem we're gonna get.
Well, yeah, the thing is, the final, I don't know what's in the final. I don't do the final. The final, it's like.
If you spelled it and you're at 100, what does it get you to?
Bueno, pues, ya sé.
No, I'm asking like in general, like. What
Well, if you're at 100 and you fail it, you get a 90.
A 90?
90.
Okay.
Yeah, that would be getting a 0 out of 0.
I don't think I'll get a 0. I hope not.
Wait, if you have an 80 and you get an 100, do you stay at 80?
It averages out.
Are you gonna curve it?
So yeah, and yes, it's going to be curved. And you can use the cheat sheet. 3 flashcards. No, you don't better. What if you mess up on something, you're the smartest person, you messed up on a lot of things for the sake of others, and then somebody else gets better than you.
Yeah, well, I'm not the smartest person, so that's not the case.
What if by some chance you get the highest grade?
That must be gone.
Because I think most of these questions may be multiple choice. A lot of them may be multiple choice.
That's so good.
Um,
That's like good because that
yeah.
Yeah, you're right.
No.
Like I'm off by one number, I'm gonna be like, oh, the closest one. I always do that.
I got it.
Even
Don't.
if it's like 1,300 and it's only like 5,000, 4,000, like 4,000 closer.
Híjole. Alright, guys. So, again, let's bring it back. So there's a case the question may not ask you for the factors. Denise, thank you. The question may not ask you for the factors or the x-intercepts. The question maybe it's asking you, well, what's the y-intercept? How do you find the y-intercept of this problem? Because this is the problem over here. How do you find the y-intercept of that?
dy by itself. That's y or x? X squared? No.
The y-intercept? Because yeah, you can write this as a function of y. You can write it as y equals. How do you find the y-intercept though?
18. Negative 18.
Yes. Negative 18 is the y-intercept. How? Why?
Y equals mx plus b. Because of that, right?
No.
Because it's...
Sorry.
Because that's our y-intercept.
Why do you say it like this?
But why is that the y-intercept? Why
It doesn't have
minus
It
18?
doesn't have the x's.
Huh?
So it doesn't have the x variable.
It doesn't have the x variable. What if it did? Then what would it be? Well, let me ask you this. At what its value, listen, at what its value do you find the y-intercept? If I give you an x and y axis,
Because isn't when you're gonna graph it, that one right there would be your horizontal?
it would, yes, which is the y-intercept. Pero to understand it a little better, where is the y-intercept? Where do you find the y-intercept? Do you find it here?
Isn't it negative 18?
It would be negative 18. The question is why? Why is negative 18?
It's over the horizon.
That you're thinking about Röntgen domain. So guys, where in here do you find the y-intercept? The y-intercept, it's on the y-axis. We said it's at negative 18, right?
Yeah.
Right there is my y-intercept. Guys, what's the value of x on the y-intercept?
Negative 18.
That's the value of y. But what's the value of x?
Negative 7.
0.
It's 0. Yeah, at this point, the y-intercept is located at 0, minus 18. This is the y-intercept. So what's the value of x has to be in the y-intercept?
0.
It has to be 0. Well, if x is 0, what is 0 squared?
0.
What's minus 7 times 0? So you're left with
Negative 18.
negative 18. That's how you find the y-intercept. If you just let x equal 0,
Okay, so what if there was an x next to negative 18, what would it be?
then everything would be 0. So the y-intercept
Would be 0.
would be 0. Yes, Daniela. Yeah, you could get something like that. So Daniela's wondering, like, what if maybe something like this? Where is the y-intercept of something like this?
4x,
Where is the y-intercept of something like this?
0.
It would be at 0. Again, the y-intercept, you find it whenever x equals 0. So if x is going to be 0 here, this would be 0 squared minus 4 times 0. Everything is 0. The y-intercept of something like this is 0. Well, again, for this particular problem, our y-intercept is located at y equals minus 18. Here's my question now. Where is my line of symmetry? Where's my line of symmetry?
Hold on. Wait, let me stop.
Did we forget this?
Silence.
Yes.
Has it been that long?
Yes.
Wait for what?
We haven't for this one, for the original one. Where's the Y-intercept? How do we find the Y-intercept? Let me remind you guys, there's an equation.
Wait, which one?
The H equation, H equals
Next will be.
no, wait, I think I forgot it.
Okay, sir.
Oh, we have an equation to find the line of symmetry.
No, we don't.
Isn't
That's not gonna be on the
the two
test.
intercepts multiplied by each other and divided in half? No, not multiplied, added.
Added. Yeah, but that takes a little work. We can use it to double check, but there's a function. There's an equation you can use. Is the H equals, I think it's minus 2A over B, or minus 2B over A, or minus B divided by 2A. That one, minus B divided by 2A. That sounds more familiar in my brain. You know what? Let's just look it up. So it's the equation of the line of you can go of a parabola.
I'll be in about 15 minutes, sir.
No. Oh, it's fine.
Are you sure?
Yeah, it's okay.
Tomorrow we can do like a little mini review.
Nah.
I don't think I
So there you go. Minus b divided by 2a.
Oh, we did that, right?
Yeah, that's the line of symmetry. Minus b divided by 2a. So yeah, the line of symmetry, that's the line that goes right through the vertex.
Negative b divided by 2a.
Yeah, so that's something you want to have, okay? That's an equation you want to have in your cheat sheet. Salud. So yeah, minus b divided by 2a, that's how you find your line of symmetry. Okay, so my line of symmetry is going to be at x equals minus b is b is minus 7. So it's going to be minus 7 divided by 2 times a is 1. So my line of symmetry is going to be at 7 halves, which is at 3.5.
Wouldn't it be just easier to do the thing with the X-intercept?
What was that? Sorry?
Wouldn't it just be easier to do the thing with the X-intercept?
It would be. But for that, you would have to find the factors first. If you have a question where it asks you, oh, just find the line of symmetry or find the vertex, then you would want to use this. But yes, guys, Daniel is stating something very, very important. This line of symmetry, it's supposed to happen right in between your x-intercepts. Oh, sometimes, Daniel, remember we get no x-intercepts. So that would also be important there. So yeah, guys, this 3.5, it's actually supposed to be right in between 9 and minus 2. Okay, remember, to find that point in between 9 and minus 2, you just add the values, just add the 9 and the minus 2, and divide it by 2. So 9 plus minus 2 gives me 7. Divided by 2 is 3 halves, 3.5, which is the same, which is exactly what we got. Okay, 3.5, that's going to be right in between 9 and minus 2. That's the line of symmetry. Well, you know that. The line of symmetry goes right through the middle of the graph. And sometimes you're asked, well, find the vertex. Find the vertex of the function. Well, we already have, remember the vertex, it's right in the middle. We already have that point that's right in the middle. To find the height of where that point is, we know it's on the middle. This is the middle. We know it's somewhere in the middle. We just need to know where exactly. Is it like very high? Is it very low? We just know it's going to be at x equals 3.5. So to find either how high or how low the vertex is, you need to take this 3.5 and plug it into the original function. So let's take this 3.5 and plug it into the function to find the vertex. Okay, again, I'm going to take this and I'm going to plug it into my function. That's going to give me 3.5 squared minus 7 times 3.5 minus 18. Let me put this in the calculator. Wait, where's my phone? Is that mine? La libreta. No, it's too. 'Cause right now everything is falling apart in my classroom. No, es que tengo un montón de cosas. No. 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 No, ¿cómo creen? Minus 7 times 3.5 and then that minus 18. So I get minus 30.25. So this thing equals minus 30.25. So this equation, Daniela, la de aquí, helps you find the line of symmetry.
Yeah, I know that part.
Okay.
I'm saying the 3.5, like, why did you sub it in?
Why did I sub it in? Because this is the x value. And this is the x value. If I plug it in, this is the y value.
Oh.
Yeah. If I plug in the x value, I get the y value in return. So my vertex is located at 3.5, comma, minus 30.25. So this is the location of my vertex. Alright, let's double check this in Desmos. Okay, so that function is x squared. The function is x squared minus 7x minus 18. We said that the x-intercepts were minus 2 and 9. Do you see that? 9 minus 2. We found the x-intercepts. We said the y-intercept was located at minus 18. Let's go down to minus 18. And there we have it. Right at minus 18. That's my y-intercept. And look at the coordinate. It's 0, comma, minus 18. What did we say was the coordinate of the y-intercept? 0, comma, minus 18. We got that right. And finally, the vertex, which is right there. Look at the vertex. You can barely see it, but it's at 3.5, comma, minus 30.25. It's accurate. Precisely right. It's very accurate. So this is pretty much everything these type of questions will ask. Alright, we have about 7 minutes left, I think. Sorry, vertex. Now, listen guys, if you were asked, guys, if you were asked, okay guys, excuse me, if you were asked to graph something like this, it's just a matter of taking all of this and putting it together in a graph. You know where your x-intercepts are, you know where your y-intercepts are, you know where the line of symmetry is, you know where the vertex is, you know everything. Alright. Now, there are other types of problems that may require you to do different things. For instance, when factoring quadratic functions, there's different ways of factoring. One of the simplest factors you will find, it's the factoring differences of squares. This is one of the easiest things you will find that you will have to factor. Factoring differences of squares. It's called differences of squares. I don't like that name because the values do not have to be perfect squares, so I don't like it, but this is what it's called. I think maybe once, like on a single day. No, you guys are going to make it. Oh, the little note cards. Yeah, if you need some, you don't have any, you can come and get some from me. Yeah, if you don't have note cards to make your cheat sheets, you can come and get some from me. Differences of squares. Technically, if you have something like this, factoring something like this, here's the process. Ready? You need two sets of parentheses. One of them is going to have the square root of the first value minus the square root of the second value. The other one will have the same thing. The square root of the first value, squared, plus the square root of the second value. Differences of squares, this is how they work. This is how you will see them. You need the square root of the first value minus the square root of the second value times the square root of the first value again, but this time instead of minus, it's going to be plus the square root of the second value. Now this will be equals. Guys, what's the square root of x squared? Remember that square root and squared are opposites of each other? It's just x. The square root and the square will cancel out. So the square root of x squared is just x. Minus, what's the square root of 9? It's 3. Now on the other side it's going to be the same thing. The square root of x squared is just x, plus the square root of 9 is 3. And that's it. These are differences of squares. That's the answer. That's the factors. Yeah, this is easy. That's why I think I only covered it once. We only did it once because it's just this. Another one. Same process. The square root of the first value minus the square root of the second value. That times the square root of the first value again, this time plus the square root of the second value. The square root of x squared is just x. The square root of 121 is 11. The square root of x squared again, it's x. And the square root of 121, it's again 11. So that's the answer. Yeah, sometimes the numbers you'll be given may not be perfect squares. Like something like this. But it's fine. Do the same process. The square root of the first term minus the square root of the second one. And then again the square root of the first term plus the square root of the second one.
And how do you know what to use plus and minus? Actually, never mind.
Yeah,
So far, I almost have like 3 jobs.
yeah. Then the square root of x squared is just x. Unfortunately, the square root of 19, it's not a perfect number. If, let's say you have answer choices and your answer choices look like decimals, then plug in the square root of 19 in the calculator. I don't think that will happen. You just write the answer as the square root of 19 and just leave it like that. Yeah, if it's not a perfect square, then it's fine. Leave it as the square root. So this will be your answer. And that's it. These are differences of squares. This is one way of factoring something. And finally, the last one, I don't think I'll have time to cover it. But the last one, it's the split in the middle method. Splitting, is that with double P? No? A single one? Is it double T?
It's double T.
Is it double D? I'm sorry. Is middle with double D?
I don't think so. Yeah.
Oh my goodness.
It is double D.
It is double T.
¿Ya ven que no saben? Chale.
You don't know. You're the teacher.
I don't teach English.
Still, we don't teach math.
We're gonna go to college. Isn't that the whole point of the used to be learning?
Here's what happened. When I went to college, I avoided taking English my whole 4 years.
And did you?
I took the English freshman course that was necessary for college.
That was not a good idea.
I took it my last year.
That was not a good idea.
Yeah, it was so funny because in there I was like a senior, and all of the rest of them were like fresh incoming freshmen, and they were like they didn't know anything. It was so funny. We had to do presentations, and because they were like right out of high school, they didn't know how to do presentations. It was so funny. I saw a lot of fun presentations. If you guys become engineers or something that doesn't require you to take English your senior year. It's gonna be the best thing ever.